We're here finishing up dilations in a coordinate plane. All right, same thing. Following the iBook notes, just doing some problems, seeing dilations in a coordinate plane. Coordinate geometry, very important. Remember, that's how they make your favorite Pixar movies. All right, so a couple ways to do this. First off, notice how the prime notation right here is smaller. All right, so it's a reduction. Sometimes I like to start there. Now, what's going on here? Notice how it's relating everything back to the origin. So it's saying like AP, let's do the one at the bottom, it's gonna be easier to talk about. CP is 7, and then C to P, or C prime to P is 3.5. So we have 3.5 over 7, which equals 1/2, or 0.5. All right, so that's how you do that problem. This one's not in a coordinate plane. This one's just floating around in space, dilating it. P was the center of dilations where we were reducing it from, condensing it. And then a few more problems. We're just going to continue to perform some translations. All right, so this one right here, we're going to be multiplying everything by 1.5. All right, so a little bit awkward number, but you know what? When you do things in real life, sometimes you don't get nice, crisp, clean numbers. You have to practice using decimals, fractions, all that stuff. So like C is 1, let's just start there. That means C prime is going to be 1.5, 1.5. Let me rewrite that. Let me just do C prime here. And I'll write C prime down here as 1.5, 1.5. B prime. Again, what's 4 times 1.5? If you don't know, just use a calculator. It's 6. And what's 2 times 1.5? Well, if you don't know, it's just 3. All right? So we get 6, 3. Boom. That right there. And then same thing with A. We have to multiply 3 by 1.5. So what's 3 times 1.5? It's kind of an awkward number. It's 4.5. So A prime is going to be at 4.5. And then 5 times 1.5. Again, it's going to be an awkward number. 7.5. So we need 4.5, 7.5, which is boom, just about right there. And that would be an enlargement because 1.5 is greater than 1, and we can clearly see that we did get bigger. So that's how you do that problem. Okay. Now, same thing, we got to deal with some awkward numbers. We got some positive, negative numbers, odd numbers. We got 1/3. We're going to be reducing this by a scale factor of 1/3. So really what I would probably just do to do this problem is like, let's look at F prime. What's -7 divided by 3? It's going to be about -2.3. And then 5 divided by 3 is about 1.7. So very awkward numbers here, but we have to learn how to deal with these numbers. D prime is going to be -1, 2.3. E prime is going to be -0.3, 1. And then G prime is going to be -1.7, 0.3. So a lot of awkward numbers, and then we just have to do our best to graph these numbers. So let's just start at F. That's -2.3, 1.7. So -2.3, 1.7, boom. I'm just going to kind of say, well, that's F prime right there. Then D is at -1, 2.3. So I'm going to put that there. E is at -0.3, 1. So probably like right there. And then G is at -1.7, 0.3. So kind of like that. And again, this was a hard one to do. I wouldn't say hard, I would just say awkward. Everything makes sense. You just divided every point by 3, but you just ended up with weird numbers. So that was kind of the hard part. All right, 2 more problems. We're going to write down the notation that represents the dilation of the pre-image A to the dilation of the other image. So basically, what are we doing right here? Let's write coordinate notation, a little bit more practicing. X, Y arrow. I'm getting smaller. And let's see. All right, let's just look at C compared to C prime. I know I'm getting smaller, so let's just do negative 1.75 divided by negative 7. All right, what is that number? Again, might need a calculator. I'm using a calculator. Negative 7, and it's surprisingly 1/4. All right, it's 0.25. So let's just write it as a decimal. You guys are allowed to use a decimal, but 0.25 x, comma 0.25 y, and that's that. All right. So basically, realize I noticed there was a reduction, so I put the final. So I'm not sure if I wrote this out yet, but it's the final over the original. So the final x coordinate for C was negative 1.75. The original was 7, so that's why that went there. Came out 0.25, 1/4. That's how I figured that out. All right, and then next we got this going on here. All right, using prime notation, I can see that it's going to be an enlargement. I'm getting bigger. And I can easily tell that I'm just multiplying by 2. So x, y arrow, 2x, 2y. And that's the answer for that one right there. And that concludes the coordinate notation notes.